Bismillah. Okay, good afternoon. So at this point we're looking at the last of the questions in the paper 2 from the St. Susie 2019 November paper. So at this point we got up until question question 8. Alright, here we go. Girlfriend, settle down. So here in the diagram below, we are told that ACBO is a piece of paper plate in the shape of a semicircle, the radius of 12. Okay, you can't see. Cheryl, why so late, my girl? You got better things to do. Nice. Now, how must I now feel? Okay, I'll cry later. Alright, so the radius is 12. The paper plate is folded so that AB, that length AB, and OB coincide. They're next to each other, no? They are right there, against each other. To form a cone with a radius of base R centimeters and a height of H centimeters. A metal ball of a radius of X is put into the cone such that the ball touches the base of the cone. Which is the spot. Okay. The first question says, that's the second question. The first question says, determine H and R, leaving answer in third form if necessary. So if you look at this here, this OA and OB is 12. If I fold it in such a way that this will coincide, then this here would be your OA or OB. Can you see that? So that is going to be 12 here. Okay. Now you see that the circumference of this circle, of the semicircle, let's call this C1 and circumference 2. Now the circumference of C1 is going to be 2 pi r divided by 2, which is pi times 12, which is 12 pi. So this is the circumference of the semicircle. But if you fold the semicircle so that OB coincide with OA, then the circumference of circle 1, that semicircle, actually forms the circumference of circle C2. Okay, if you do the experiment, you'll see that that outer edge, C1, will be the C2 in the cone. Okay, which means to say now, I can actually work out R, my radius. So we say C2 is equal to 2 pi R, but we know that C2 is equal to C1, which now means to say that, which implies that 12 pi is equal to 2 pi r. So your radius, if I divide both sides by 2 pi, is actually 6. So the radius r is 6. Okay. So now to calculate your height, as you can see, it's going to be a right angle triangle. So I can apply the theorem of Pythagoras. So your h squared is equal to 12 squared minus 6 squared. Okay, which now gives our h value to be the square root of 12 squared minus 6 squared, which is 6 root 3. So that height is 6 root 3 centimeters. And since the question says I must leave the answer in simplified third form, so I leave it like that. Okay, you guys understand? So the h is going to be that thing, which is 6 root 3. Okay. Is there any problems here with 8.1? Okay. Sorry? But the answer for h is 6 root 3. Okay, I've made a mistake there. I've written 24. It's supposed to have been 12. Okay. Thank you. You. Right. So let's look at the next question. The next question says, in 8.2, the cone containing the sphere is filled with water. Assume that the sphere remains in the position. Determine the volume of the water in the cone. You may assume that x is equal to 2 centimeters. So in other words, I must calculate the remaining volume of the cone. Not so. So volume the volume of the remaining space. The volume of what is remained is going to be the volume of the cone minus the volume of the sphere. Not so. So the volume of the cone, how do you calculate the volume of a cone? It's a third area of base times perpendicular height minus the area of the sphere, which is 4 over 3 pi r cubed. Okay, so it's going to be a third. The area of the circle, or the area of the base of the cone, is going to be pi r squared. Pi is going to be 6 squared times the height, which is 6 root 3, minus the area, the volume of the sphere, which is 4 over 3 pi times your radius. The radius of the sphere is of course 2, as given there. So it's going to be 2 cubed. Okay, so that gives us a third pi times 6 squared times 6 root 3. We're going to put the answer minus 4 over 3 pi times 2 cubed. Gives us 358. Is that correct? 358. 358,27 centimeters. Okay, so it's a good question, huh? Well, I think it was. Let's go to the next paper, next question, question 9. Question 9, we are told that ABC is a tangent. So if ABC is a tangent, what do we know? We know that this angle here is equal to that angle. Why? Tan chord theorem, as well as B1 is equal to G1 and so on. Then we are told that BG is parallel to BE. BG is parallel to that. So if that is parallel, what do we know? G1 is going to be 18, alternate angle. So that's also 18. Not so. Then we are told, okay, so the angles are given as it is given on the diagram. So I'm just going to pull this over as the space is needed. So the question says, in 9.1, okay, so normally if it's a tangent, what I do is I put markings here, at least. Okay. So we are asked to calculate the size of angle F. Okay, so that is angle F for 2 marks. Now you see, what do you notice here? F for that angle forms a cyclic chord. Not so. So I can say that angle F, this is now 9.1, angle F is equal to 180 minus 80 degrees. Why? Opposite angles of cyclic chord. That will give you 100 degrees. Not so? Right. Then you also calculate B1, angle B1. Okay. So we look at B1. B1 is this angle. But B1 is the same as G1. Why? Tan chord theorem. But G1 is the same as 80. Why? Alternate angle. Can you see that, people? So 9.2, we are told that G1 is equal to 80 degrees. Alternate angles with ED being parallel to GB. It is 80. Then B1 is also equal to 80. Why? The tan chord theorem. Don't just say tan chord, no? Say tan chord theorem. Okay. You all okay with that? Let's carry on with our lives. Then in 9.3, they ask you to calculate E1. 9.3 they ask you to calculate E1. But E1 is formed in that cyclic quad. Not so. So which angle do I need? I need B2. Or if I calculate G2, done the job as well. Sum of triangles. But simple, at this point we can calculate B2. Why? So you're going to use angles on a straight line. So 9.3 we're going to say that B2 is equal to 180 minus 80, which is 100 minus 15. And the reason is angles on a straight line. So it's going to give you 85. Is that correct? 85 degrees. What you notice, I'm populating this diagram. Everything I've added and calculated, everything I've calculated, I'm adding to the diagram all the time. So at one glance you can see what is calculated and what is known at that point in the diagram. Then I wanted to calculate G2. Okay, so B2. No, I didn't calculate E1 yet, sorry. So E1 is equal to E1 plus 85 is going to give you 180. Yeah? So it's going to be 180 minus 85, which is 95. Reason? Opposite angles of cyclic quad. Okay, so that's 95. And now we go to the next question. The next question says G2. Simple. How are you going to calculate G2? Sum of triangles. Not so. So angle G2 is equal to 180 minus 80 minus 95. Why? Sum of triangles in this triangle DEG. So it's going to give us 5 degrees. Okay, any problems here? Let's carry on. Question 10. Question 10, we are told that in this figure, O is the center of the circle. Okay, let's reduce this a bit. In the figure, O is the center of the circle. Then we are told that AB is equal to BC. Okay, so which means to say that this angle here is equal to that angle there. Angles opposite equal sides. Not so. Then we are told that ABO is equal to CBO. Okay, so already I'm seeing a congruent triangles there. No? Then we are told that the angle is X. Okay, so I'm just going to move this over. So again, to have the diagram in focus. Okay. Basically, that's what we have there. So we're going to fill in this here to indicate that those angles are equal. You see, that wasn't given equal on the diagram. That is why I put it in there as well. Okay. So let's see what's the first question as entailed for us. We are asked to determine, put this here. We are asked to determine determine AOB in terms of x. So AOB, this angle here in terms of x. So you see as angle at center is twice angle at circumference. Can you see that, people? So what is AOB? AOB will be 2x. Angle AOB is equal to 2x. Why? Angle at center equals 2 times angle at circumference. So there I put 2x. Do I have to write that whole thing there? Yes. Okay? In the past we just used to say angle at center. No? But you're going to be penalized if you say that. Okay, you must say angle at center is twice angle at circumference. Okay. In 10.1.2, the question says, hence determine AOB ABO in terms of x. So it's this angle the other one in terms of x. Okay. Is this 90 here? Is that given 90? It's not 90. Okay. Okay, so if you look at the shape here, yeah, that wasn't given 90. That's how yeah. But anyway, you see, if you look at what is given here, what do you notice? These two lengths are equal, and of course AO is equal to OC. Why is AO equal to OC? Sorry? It's your radius there, not so. So that there is equal to that. Then we are told that AB is also equal to BC. Why is that equal? Because that was given to us. So what type of shape is this then? A kite. Not so? It's a kite. Okay. So therefore, AOCB is a kite. Alright, why? So two pairs of adjacent sides are equal. Of course, that is the case, it's now a kite. Which means to say that this is all 90 degrees here. Why? Because the angles are perpendicular in a kite. Not so. I feel like there's an easier way, but let's just cover this quickly. So we're going to say that B, there's no marking here, there's a T, sorry. So you have B, TC is equal to 90 degrees. Why? So the diagonals are perpendicular in a kite. Diagonals are perpendicular in a kite. Okay, so there's 90 degrees. So then TBC, this angle here, is going to be 90 minus x. Or I could have said 90 plus x plus TBC adds up to 180, sum of triangles. Okay? And then say TBC is 180 minus 90 minus x, which is 90 minus x. Reason? Sum of triangles, and it's in triangle BTC. So therefore, ABT, and that's the angle they wanted. Sorry, ABT or ABO. In this case, ABO is the question one. So it'll be 90 minus x. Why? So it's given that ABO is equal to angle CBO. There's 90 minus 6. I feel like this method is about 5 marks, but it's given 3 marks there. So just check, is there a quicker method or a different way I did it in the memo? Just check there. Because I'm going to use the other color, I'm going to use blue. Okay, yes? OAB, yes?
Is equal to OBA.
OBA, yes?
But I didn't get right with that because, you know.
Okay, because it's a kite.
Yeah.
Yes?
But he didn't do it's a kite, so, oh yeah. And then the reason why the animals toxic equals are, and then you said ABO is equal to 180 minus 2x divided by 2 is equal, ABO is equal to 90 minus 6. And that's all.
Okay, so the memo is short in this spot. Okay, so we have to say it's a kite. Why must we say it's a kite? So it wasn't given to us as a kite. Okay. So that is the one thing I've shorted if I'm going to go with that later. Alright. Let's carry on. So now, for 6 marks, we'll probably need the space here. So what I'm going to do is I'm going to put in what I've just calculated. So this is 90 minus x, and this is a what's the name now? No? Kite. Okay. So now the question says, I'm going to use again blue, in 10.1.3, we're told that if TO is equal to TB, so this is a ratio now. So TO over TB must be equal to 1 over 3. Okay. Then we are told that OA is equal to R, so that's R and R. And OB is perpendicular. OB is perpendicular to AC. So we already see it's perpendicular. Now they also telling us it's perpendicular. Show that AC is equal to that thing. So if we're looking at AC, AC is this length here. This is our length. Not so. So if we can calculate AT, then I multiply by 2, I'll get AB. Okay, why? So the diagonals bisect each other in a kite. We already proved this was a kite. Okay. So TO, what is TO? OT is going to be here. Okay. TB minus x. I'm going to pause the video here before we waste a lot of time. Okay. Okay, what I'm overlooking all the time is that this is also R. Which you are radius. Can you see that? Which means now to say that the radius, if TO over TB is 1 over 3, then OT plus TB is equal to R. Can you see that? So if we cross multiply here, then TO 3 times TO is equal to TB. Not so. Well, what I'm interested in is OT. Why am I interested in OT? Because I want to set up the theorem of Pythagoras. Can you see that? So OT is equal to a third TB. Okay? So TB, I'm going to fire. So that's in terms of TB, OT, TB. I'm interested in OT. Let's go the other way around. So I'll skip that one. So if TB is 3 times OT, then I'm going to have OT plus TB, which is 3 OT, is equal to R. So OT is going to, 4 OT is going to be R. So OT in terms of R is going to be R over 4. Okay? Then they actually wanted AC. So I'm going with AT first by using Pythagoras. So AT squared is equal to R squared minus R over 4 squared. This is Pythagoras with OTA equals 90 degrees. Do I need to say that's a kite and perpendicular? No, I already said that in my previous question. Okay, so this is simply going to be R squared minus R squared over 16. Okay, so that is 80 squared. Okay, so the square root thereof will give you 80. So that's going to give you, now if you change this to 1 fraction, that will be 16R squared minus R squared, which is the square root of 15R squared over 16. Okay, that's 80. But AC is double that, not so. AC is 2 times 80, which is simply going to give us 2 times the square root of, now the square root of 15 remains 15, the square root of R squared is R, and the square root of 16 is 8. And of course now 2 goes into 2 once, sorry, it's not 8, it's 4. 2 and 2 once, 2 go into 4 twice. So the answer is R root 15 over 2, which gives you what they asked for. Okay. Was there an easier way I did it initially? Sorry? AC, yes? Why? Sorry? You don't? Okay. But does this make sense? Okay. If you don't understand, you can watch the video. Okay. So that is that thing. Okay. This was actually a nice question. Question 10. Listen, we only got like 30 minutes left. How much? Okay, so we got 30 minutes to wrap this question up before the electric goes out. Okay. So, and also the link to the paper is in the description box below as well. Okay. So we're told that in the figure, AC and CR are tangents to the circle at B and R. So if these are tangents, people, then BC is equal to CR, which will now also include the fact that B1 is equal to CRB. Okay, tangents from common point and angles opposite equal sides. Then we are told that O is the center of the circle. So if this is the center, then we know that angle at center is twice angle at circumference. So that angle is double that angle. And many other things, okay? We know that those lengths are equal, with the resulting in those angles being equal, and so on and so on. Then we are told that B, R, K, S, and D are points on the circumference of the circle. So there are cyclic quads that's also being formed. Okay? Then we are told that BE is perpendicular. So if these lines are perpendicular from the center, then those lengths are equal. You see, anything is coming to play here. And why is that equal? So that's perpendicular from center to chord by 6th chord. Then we are told that BK is your diameter. BK is your diameter. So if this is your diameter, people, then that is 90 degrees, and that is 90 degrees there. Okay? Okay. I don't know why it's doing this now. Probably tired already. No? Right, but anyway. So if that is your diameter, those angles are 90. We are told that these lines are parallel. DC is parallel to that angle there. So then these angles are coincident, so that's also 90. And if it's alternate, then this angle here, which is O4, is equal to K2. And many other things is evident. Okay, you guys okay with that? Alright, so let's just take it off. So the first question says, find 3 other angles equal to x. So 10.2.1, 3 other angles that's equal to x. So we said that this whole angle here is x. So it's going to be BRC is equal to xy, because it's, firstly, I have to say that BC is equal to CR. Why? Tangents from common point or external point. Okay? So that is an xy, because that's angles opposite equal sides. Okay? So that's your first angle. Then your tan chord here, you see there, your triangle being formed there. So see K2 is going to be a tangent. You all agree with that? So K2 is x. So angle K2 is equal to x because of the tan chord theorem. Don't just write tan chord. And then these lines are parallel. So I've already indicated that O4 is the same as K2. So O4 is also equal to x. Why? Because alternate angles with a DO being parallel to KR. When you say alternate, corresponding or coincident, you must couple with which lines are parallel. Mr. Steerman, you okay, my girl? Doesn't look like this geometry is interesting you, no? Something else that's getting you laughing. Alright. You all okay with that, people? 6 marks in the bag at this point. Then we are told, determine B3 in terms of x. So we're looking at B3. Where B3 lie? B3 here. Okay, so for B3, we can go angle at center is twice angle at circumference. Can you see that, people? So we're first simply going to say, whoops. So B3 is going to be a half O4. Why? Because the angle at center is equal to 2 times angle at circumference. Okay, so there goes a half x. Okay. As we look at the next question, the next question says, prove that so remember here's a K here. Okay. The question says prove that prove that B, so I'm going to use a different color here, that B, C, R, O, B, C, R, O is a cyclic chord. I'm going to prove cyclic chord is one of 3. It's either the bow tie, the angles in the same segment, the converse zero, or exterior angle is equal to the interior opposite, or what's the other one? Exterior angles equal opposite angles are supplementary. Not so. So if we look at this here, there's many lines here. So if we can prove that this is X, we've done the job. Can you see there? These that angles in the same segment. Okay, you all agree with that? People, we are running out of time here. I want the video to cut by the time the electric are out, so we're going to go a bit faster through this. Also, I'm trying also not to make a mistake here. So 10.2.3, we said that O1, you see that those angles, that angle is actually equal to x. Why? So it's vertically opposite to O4. You guys understand? So O1 is equal to x. As you can see, it's vertically opposite. So we say, since we state the obvious, that angle O1 is in fact equal to BRC, which is equal to x. Therefore, BCRO is a cyclic quad. Why? Because you can either write the converse of angles in the same segment or equal angles subtended by line BC. Or you can just say equal angles subtended by chord BC or by chord, doesn't matter. Or by line, doesn't matter. So all cyclic quadrilateral properties are now evident in that shape. Okay. Then the next question says, the last question for 3 marks, we are asked to prove that ABC is a tangent to the circle. So ABC, so ABC is a tangent to the circle through BOE. BOE. So people, if that was a circle going through there, and if that was a tangent, then this angle here would have been equal to that angle. Why? Because of the tangent theorem. But now that we need to prove it's a tangent, we prove the converse of the tangent theorem. We prove that the tangent theorem actually can be applied to that diagram with those shapes, with those angles. Okay? So as you can see, that angle is 90. But we know that this is also 90. So 10.2.4. So we say that BO is 90. Why is that 90 degrees? Because radius perpendicular to tangent. Can you see it? For this big circle, that's given a tangent there. Not so. For the original circle, that was a tangent. So, and it's from center to circumference, so the radius is perpendicular to tangent. So now we state the obvious. We say since ABO is equal to AEO, which is equal to 90 degrees. Can you see that? Therefore, ABC is a tangent to circle through B, O, and E. Why? Because either you write converse of tangent theorem or angle between line and chord, angle between line and chord equals angle in the alternate segment. And that is the proper reason for the converse of the tangent theorem. Okay? Any comment on the paper? Yes? Is you going to ask now, is your paper going to be this easy? Oh, okay. Yes. 6.2.4. Let's go back.
No, that's fine, sorry. 10.2.
Sorry? 10.2.4.
This one.
Yes, this one, yes.
Why don't we just use B1 and O1?
B1 and O1. Let's go. B1 and O1. 100%. So easy, so much easier. Not so. Here we don't have to even state anything else. We just said since, we're going to just say since B1 is equal to O1, which is equal to X. Therefore, ABC is a tangent to circle through BOE. Why? Because angle between line and chord equals angle in the alternate segment. Well done. Which way did that do in the memo?
The one that I just taken.
Oh, you copied from the memo. Nice.
It was just really
Nah,
hard.
joking, even. Alright, anything else? You see, normally when we sit and we write up the memo, then we allocate marks to it, then we see which is the quickest method to do it. So that is quicker. So okay, but you'll see sometimes in my memo I go the long method, but that is what I saw at the time. Okay, when you're teaching in front, it's what comes to mind first. Because I am not teaching from a memo, I'm teaching from what I see. Okay. Anything else? Right, so what is the next paper? Do we choose the next paper already? Yes, what is the next paper? November 2018. That is Aunt Susie's paper, no? Okay, and stop here.